Hi and welcome to Kalen Dash Tech lesson on MPLS Layer 2 VPN using Circuit Cross Connect, so CCC. Okay, we're going to use it looks like the same topology as the Layer 3 VPN, and primarily it is with a couple of changes. So we're going to produce this Layer 2 VPN so that we can ping from London customer site A across to London customer site B. As you'll notice, a couple of changes. GE000 is now 10.10.10.2, and on site B, London customer, GE000 is the peer address for the /30 of 10.10.10.1. The GE000 interfaces, you'll note on the provider edge, have no IP addressing assigned to them. This is to show that it is in fact operating at layer 2. Now, there is a little bit of important information first. We don't need to have an actual presentation for this. It's a bit of information for you. On the P routers, or the internal network, including the G005 interfaces of the provider edges, it's important to note that we're going to set an MTU of 4000. And that's primarily because layer 2 VPNs don't support fragmentation in a provider network. So it's pretty critical that a provider network supports the largest frame that CE devices can generate. But what's really important is that's after the MPLS and VRF labels are added. Okay, they'll be added by the provider edge devices. So the config we're using here leaves the CE devices at the default 1500 MTU, but we configure the P routers to support a 4000 by MTU. So the configuration will avoid any discards that we may see by ensuring that the CE devices can't exceed the MTU in our provider network. Okay, so with that being said, let's go ahead and continue with the actual configuration and have a look at how we do this. So we're going to start with the customer site at each end. It's a pretty straightforward piece of configuration. So in this network that we're utilizing here, that is, of course, probably a little bit more complicated in your live networks. So first of all, let's go into edit mode and we'll just do a run show configuration, and we'll do it as a display set. Okay, and what you'll notice is we've got our normal login class, a normal login user, hostname, services SSH, the interface that faces the provider edge, which is 10.10.10.2, as I showed you on the topology, the loopback at 3333, and the router ID. Okay, so what we're going to do is, as we're extending the OSPF across the two different sites, instead of having the loopback in as passive, we're actually going to put it in so that it partakes or participates in the OSPF network itself. Okay, so let's do set protocols OSPF Area 0000, so it's area 0 really, and we're going to put interface loopback 00, and we are going to put in interface GE-000.0. And that is it. That's all the configuration we need to do on this system. So let's just go back and to the configuration again. So you can take a note of this, pause the video or whatever you want to do, but those are the two lines that we've just added in. Okay, so let's go ahead to London customer B and do exactly the same. And again, I'll show you quickly the configuration. So show configuration, display set. Okay, and it's exactly the same. So in this one, again, we need to do set protocols OSPF area 0000 interface, and we're going to pop in there LO0.0, and we're also going to pop in G000, G-000.0, and we'll commit that, and we'll do a quick run show configuration display set. and you'll notice, again, pause it here if you want the full config, that we've just added in those 2 lines. So the next router we're going to go to is we'll go to prouter 1. Okay, and we're going to log on to that. And the only thing we need to complete here, so we'll just go edit and we'll do a run show configuration. And we'll do it as a display set. Okay, so again, we've got our login class, our users, our SSH, and our interfaces G004, which goes to prouter 2, and PE site A. Okay, as I said, we need to ensure, well, we've got our LDP and MPLS, as it's always been. Okay, so we need to ensure that we set an MTU of 4000 on these interfaces that are our internal provider network. So let's do set interfaces G-00 4 MTU 4000. Okay. We also need to do that on GE005. So we're going to pop that in there and we're going to commit that. And then we'll show the configuration again, run show configuration, and we'll put it as a display set. Blimey, my typing today, my apologies. Display set. Okay, and you'll notice that we've just added in, again, pause it if you need to. We've added in that line there, and we've added in this line here to accept a larger MTU. Okay, right. That's prouter 1. Let's go to prouter 2, and we're going to do exactly the same on prouter 2. From a configuration perspective, there is no difference, so we'll just go ahead and do set interfaces G-005 MTU. Not exactly sure what went on there. Let's do that again. So set interfaces G-005 MTU, and it's 4000. Okay, and we need that on 4 as well, GE004, and that's it completed on this prouter on prouter 2. Let's just do a quick run show configuration display, and we'll display the set, and you can see it again. So again, we have the 4000 on G004 and the 4000 on G005. Okay, so what we're going to do now is we're going to move on to the PE, the provider edge routers. This is where the meat of the configuration exists that you are really going to want to see, I guess. So let's go into edit mode and we'll do a run show configuration display set. Okay, again, we've got our login class, user, host name, services, and our G001, which goes to Bristol, but we're not utilizing that in this lesson, and our G005, which is actually what goes to the P router, and this is the router that we're in, this is the interface that we'll be interested in. Okay, we have our loopback configured, we have our autonomous system number, our MPLS interface, and our LDP and ISIS. So the first thing we need to do, if you remember, we said it's got to be 4000, and GE005 is what is our internal facing, provider facing network interface, or our interface. Okay, so we need to do a set interfaces G-005 MTU 4000. Okay, that's the first thing we need to do, is to ensure that we've got that MTU configured. Okay, so the next thing that we're going to work on here is if you notice in the configuration, we have no GE 000 configured, only 001 and 5. Okay, and actually we need GE 000, but we are not configuring an IP address. So let's configure this how it should be for this circuit cross connects. Okay, so we're doing a set interfaces GE-000. Okay, and the first thing we need to do is we need to do it on the actual main interface stanza rather than the unit stanza. Okay, so what we're going to do is we're going to put in here an encapsulation. Okay, and the encapsulation is going to be Ethernet CCC. Okay, and let's start on the unit 0 information now. Okay, so unit 0, and we're going to put on there a description. So unit 0 description, and we're just going to call it I don't know, to London cust A. That's our description, and we have to put in here a family as well, and obviously our family is going to be CCC, circuit cross connect. Okay, now we can commit that. We can go ahead and commit that. So that's our interface configurations completed on this one. So what we're going to do now is we're going to go ahead and we're going to set the protocols up. So we're going to set our internal BGP between the provider edge routers. So BGP group, and again we'll call it internal peers, and the type internal. Okay, we also are going to want in there our local address. So let's pop in there our local address, which is going to be 4.4.4.4. And we're now going to put in something new, a new command. Our family in here. You remember before we'd normally put family INET or something like that, okay, or INET 6, whether you wanted IPv4 or IPv6, but this is at layer 2, so we have to put in here L2VPN signaling, and then obviously we have to have a neighbor. So we're telling it here that we're going to be sending L2 VPNs between the two PEs. Okay, that's what we're telling it here. Okay, so that's our neighbor configured, and we're going to commit that. Now, what we really want to do before we get the L2 VPN up and running is we're going to go to site B and we're going to complete that up to this point so that we can get the internal BGP established. Okay, the peers established. So let's log on to this one, and we're going to go to edit, and we'll do a quick run show configuration display set. And we'll see there's no difference. Login class, user, services. There's no GE000. There is a 1 and a 5. Okay, 5 is what is our internal provider facing interface. So that's the one we need to do the MTU size on. And we have our MPLS is an LDP as always. Okay, so let's do our set interfaces. GE-005, okay, and we want an MTU of 4000 on there. We can commit that, so let's go ahead and commit that. Then we need to set our GE000 interface that faces the customer edge, okay, and if you remember, the encapsulation type is going to be Ethernet CCC, okay. And this time we're going to go for unit 0, and we're going to give it a description, and we'll call this one to London site B. Okay, and we also needed to give it the family that we're going to be utilizing, and the family is CCC, circuit cross connect, and we can commit that one. Now we'll set our BGP. So let's our internal So we're going to say set protocols BGP group, and we're going to call it internal dash peers, and the type internal, obviously. And the local address this time is going to be 5.5.5.5. Okay, and don't forget we have to put the family in here again. So the family is going to be L2VPN signaling. Okay, and we need to put the neighbor, which is going to be 4.4.4.4, and we can commit that one. Now what we'll do is we'll do a quick run show BGP summary. Let's just wait for this to come up. So at the moment it's still active. Open, confirm, and established. Okay, so we've got it in an established state now. Now it tells us here that we've got our forwarding table ready, okay, for this layer 2 VPN, BGP layer 2 VPN. But we're not receiving anything. There's nothing active. There's nothing been accepted as yet. So what we need to do now is we need to go back to PE site on site A. Okay, and we're going to now configure up our routing instance. Okay, so let's do set routing instances, and we're going to call it L2VPN1, and the instance type is going to be a layer 2 VPN. We also need to put in there the interface. Okay, so let's pop in there the interface of GE000.0. Okay, and we need to put our route distinguisher, and this time we are going to use the loopback interface address. So 4.4.4.4 colon, and we'll call it 12. Okay, and our VRF target. And the reason I'm doing it differently is to show you that you can utilize it differently if you wish to. So our VRF target is target colon 65533, which is the ASN number if you remember, colon 12. That's our target. Now we have to do our protocols. Okay, and our protocols are layer 2 VPN, and the encapsulation type is going to be Ethernet. Okay, we can do our interface description on here as well. Okay, so we go back to protocols L2VPN interface GE-000. We'll do it on unit 0 description, and we're going to do it in capitals. We have to put speech marks because there's going to be a space, and we'll just say edge link to London Cust A. Okay, then we're going to put in, we now have to put in our site information. Okay, so let's do that now. So we have to put a site number for each end, or site identifier. Okay, so we're going to put here site, and it's a name, and we're on the A end, so we'll just call it CE-1. Okay, and the site identifier, okay, is going to be 1. That identifies the site A end for this particular customer. Okay, and we also have to put in there our interface, excuse me, our site CE-1, and our interface this time. Okay, and our interface is GE-000, okay, .0, and the remote So we're now telling it, we are telling it the remote site ID where it has to go to. Okay, and the remote site ID is going to be 2. Now we have one more command that we put in here, okay, where we can do a set a label switched path. So we go to set protocols. Now this would be more relevant. I'm putting this command in here because I want to show you this command. This is going to be more relevant when we utilize RSVP, okay? But I want to show you it anyway. Label switched path, and we're going to give it a name, and we'll call it LSP-2PE2, just a name. But we then have to say 2. Where's it going to? So we'll put in there 2 5.5.5.5, okay, which is the loopback address of PE2, which is what we want. So we're telling it go from here to there, okay, on this path. So we're going to pop that in as well, and we'll do a commit check to show you that that should be fine. And that, so we'll have a quick look at the configuration again. Run, show, configuration, display, set. And you might want to pause it here again. So we'll go through it line by line. Look. So we've got our MTU on there. We've got our encapsulation on G000, MTU on 005. We have our MPLS, INET addressing, ISO addressing, loopback interface, autonomous system, and our label switched path. Our BGP group, okay, our LDP, and our routing instances. So you might want to pause it there if you want to have a look at that configuration, okay? So what we'll do now is we'll go to PE Site B and we'll quickly run through the same configuration, okay? So we've done our BGP group. So what we've got left is we're going to set on here, we're going to do a configuration now of the actual instance, and then we'll put on the label switched path. So let's do set routing instances L2VPN1, and we are going to do the instance type. It's going to be an L2VPN. Okay, so that's the first command that we put in. Then we can use the up arrow, and we have to put in there again the interface. Okay, sorry, I've gone back one too far. So we've put in there the interface, and the interface is G-000.0. Okay, then we put in our route distinguisher, and the route distinguisher is going to follow this end because it's for the VPN going the other way. Okay, so we're going to put 5.5.5.5:12, and we have to put in our VRF target, and our VRF dash target is going to be target : what are we going to put in here? We'll put in here the 65533:12, because that does have to be the same. We're telling this where the far end target number is. Okay, so it has to be the same, that one. Okay, now we're going to put in our protocols, and our protocols are obviously going to be L2VPN. Okay, and the encapsulation type is going to be Ethernet. Okay, and we'll put in an interface description. So we're going to go interface G-000.0 description, and again we're going to call it link to London Cust B. Okay, that's that part of it. And now we need to put our site identifiers, which are going to be the opposite way round to the other end. Okay, so we're going to tell it our site, which is going to be C-2 because it's this end. Okay, and we're going to put in the site identifier, and the site identifier is going to be 2 for this end. Okay, and now we put in there for site CE2, we put in there our interface, which is G-000.0, and the remote site ID, which we now know is 1. Okay, so that's how we've identified each end and how the system will understand and know that. Okay, so that's how we've completed that particular portion of it. Now we just have to add in the label switched path. So we're going to do set protocols MPLS label switched path, and we're going to call it its name of LSP to P1, LSP-2-PE1, okay, and 2 4.4.4.4. And we are going to commit that. Okay, and now what we're going to do is we're just going to run some little tests, all right? So we're going to do some verification now to ensure that this actually works, okay? And that we can prove that it works. So we're going to exit out of the configuration mode, okay? So let's exit out of configuration mode. So the first thing we need to do is verify that the layer 2 VPN routes are in the routing table. Okay, and we can do that 2 ways. So we can do a show route table bgp.l2vpn.0, and there it is. It's in there. Okay, so we know that it's in that we're receiving it this end. Okay, because if you know it's 5555:12. Okay, but we're actually at PE site A. How can we verify it again? Well, we can do a show route table L2 VPN1.L2, and we're just going to say VPN.0. Okay, and we see them both in there. So we see the L2 VPN being advertised out, and we see the one being received via BGP with its label on the end, its push label. Okay, so that's how we can verify it from that side. Now what we're going to do is we're going to verify the layer 2 VPN connection status. So we can do a show layer 2 VPN connections. Okay, and this will tell us our status, and it tells us it's up. Okay, the layer 2 VPN is up, and the site, okay, to where we're going to. All right, so the connection site is site 2, and we know it's site 2 because we're on site 1 here. Okay, and the remote PE, there it all is, 5555, negotiated, control word yes. And it shows you the incoming labels and the outgoing labels. Okay, it tells you the local interface, and it tells you that it's up and what the encapsulation type is. It tells you everything there, okay, that you need to know to see if it's actually up. So, how can we verify that though? Well, we can ping the remote device using a layer 2 VPN connection. So what we'll do is we'll do a ping MPLS layer 2 VPN. Okay, interface G-000.0, and reply mode is going to be IP-UDP. And let's see what we get back. Okay, first one missed, but that's possibly because it's just to do with Eve NG. Could be a bit slow locally. My machine is running a little bit slow at the moment. So that's because of the internal mechanism at the moment of my actual PC. It's a little bit slow. Got quite a lot of things running on it at the moment. Okay, but that proves that side of it. So let's also, so we've pinged the local device there in reality. So let's ping the remote device and see what happens there and see if that works okay. So we'll do ping MPLS, layer 2 VPN, instance. The instance is going to be L2 VPN1. Okay, and the remote site ID is going to be 2, and the local site ID is going to be 1, and we want it in detail. So we should see our labels here as well. Okay. And so that's going across the layer 2 VPN. We see our labels in each section. Okay. These are all the packets, and that's fine. That works as well. So what we can do now is we can move to verification on the actual customer edge devices. So let's exit out of here and go back to our operational mode. And so the first thing we can do is we can go show OSPF neighbor. Okay, and that shows us, look, straight away, well, we must be getting that information from somewhere because our interface this end is .2, but we're seeing .1. Where's it seeing it from? Oh, G000, yep, full. Oh, and the ID's 9999. We know that's not our end. We know that's London customer B. Okay, so we are actually seeing the neighbor. Let's have a look at show OSPF route. Will it be in there as well? Yes, it is. There's 9999. Okay, and it shows it as an intra router, even though it's in a remote network, or it's at a remote network site, because we've extended that over a layer 2 VPN. So now what we need to do as well is let's see if we can ping the interface. So 10.10.10.1 will be the far end. Yes, we can. Now, can we also ping it with the correct the correct packet size without it being fragmented? So what I'm doing here is I'm going to do a ping, and it's going to generate 1472 bytes of echo data. Okay. Now there's going to be an additional 8 bytes of ICMP and 20 bytes of IP header are going to be added to that. So it'll bring the size to roughly 1500 bytes. Okay. So if we add the do not fragment switch on this ping methodology that we're going to utilize, it ensures the CE device can't perform fragmentation based on its local MTU. Okay, so the method that we're about to use confirms that no fragmentation is possible or needed, okay, when it's sending a standard length Ethernet frame between the CE devices. So let's have a look at this command, and we'll see it in action. So we're going to ping 10.10.10.1, okay, and we're going to give it a size of 1472, and we're going to say do not fragment. That's what we're going to tell it, and we only want a count of 2, so we'll just do a count of 2 packets, and let's see what we get. Okay, that is also successful. Can we also ping 9.9.9.9 from this end? Yes, we can, and that's all going across the layer 2 VPN. Let's have a look at a trace route to 9.9.9.9. Let's see what we get from the trace route, and it goes directly to it. You see, we don't see any hops in the middle. We see none at all because this is layer 2. So between the CE interfaces, the provider edge interfaces, it's at layer 2. So you are not going to see any hops in between. You'll just see it going directly there. Okay, because reality being that the way we've configured it now, if we have a look at our topology again, this interface now sees its neighbor as this interface. So when you do a trace route from here, it will go directly to the loopback. There will be no hops in between because this is layer 2. All of this is now layer 2. Okay, so that's a circuit cross connect layer 2 VPN configured for you. So you can utilize this in your environment, of course, and you just create separate VRFs for different customers. Okay, and that's how easy this can be. Obviously, it's going to be the larger your network becomes, the more complicated it becomes, but theoretically, it's no more complicated than this. Okay, so if you have any questions, please let me know. Thank you. Hope you enjoyed this lesson. Bye bye.